In the second video for section 4.1, you're going to learn about exponential decay. In this example, we have g grams, so a certain mass, of tritium, and tritium is a radioactive form of the element hydrogen that's sometimes used for its light-emitting properties. So if you might have seen this on the dial of certain watches to make the markings glow in the dark. And it's also used in other similar kinds of applications. So back to the problem, if you have g grams of tritium, then 1 year later, there will only be 0.945 times g grams of tritium left. So what that means is, since we're multiplying by a number that's less than 1, the amount of material that's left is less than what we started with. So we started with g, and now we end up with a smaller multiple of g. So this is because tritium is radioactive. Once it emits radiation, there's slightly less of it remaining. In this example, we're going to have 50 grams of tritium to start with. And I want to find a formula for the amount of tritium left after t years. So think back to the formula for exponential functions. It's going to be the initial value times the base to an exponent. So the way this works for exponential decay is that the amount left after t years is the initial amount times the decay factor. There's a mistake here. Since this is decay, we should use the word decay instead of growth. And then we have the exponent t. So the decay factor is playing the role of the base a. Let's just plug in our numbers. The initial amount that we start with is 50 grams. And then our decay factor is 0.945. And then our exponent we just copy down, t. So now that we have a formula for the amount of tritium that's left over, I want to figure out how much tritium I'll have after 10 years. So we take our function, our exponential function, and we plug in 10 for 10 years. So that's 50 times 0.945 to the 10 power. You'll want to enter this formula into a calculator or your computer, and what you end up with is 28.40 grams. And this number has been rounded to 2 decimal places. So after 10 years, there's a little bit more than half of the initial amount of tritium remaining. Next, we'll graph the amount of tritium left over for the first 40 years using Desmos. Open a web browser with desmos.com and hit the Start Graphing option. And now we'll just enter our formula. So this is G, let's just use a capital G to be consistent, and then 50 times 0.945 to the t power. So you can see The graph here doesn't show anything yet. Let's just zoom out a little bit so that we can see. So here's the first 40 years of decay of our tritium. We start here with 50 grams of tritium, and after 40 years, there's much less remaining. So this point is about 5 grams of tritium. So over 40 years, we now have 1/10 of what we started with. Next, you will learn how to find the half-life of a radioactive element. The half-life of a radioactive element is the amount of time that it takes for half of a given amount of the element to decay. So let's find the half-life of tritium. Since we are beginning with 50 grams, we need to figure out how long it'll take for half of it to decay, so we multiply 50 by a half and get 25 grams. So we need to figure out how long it'll take to go from 50 grams down to 25 grams. So what this means is we'll have to solve the equation. Here on the left side, I have the function for the amount of tritium left, 50 times 0.945 to the t power. And on the right side, I have the amount that I want left over, 25 grams. In order to solve this equation, we'll have to use the crossing graphs method in Desmos or a calculator. Let's go back to our Desmos tab where we've already graphed our function for exponential decay of tritium. Since we're going to use the crossing graphs method, we also need to graph the right-hand side of the equation. So we need to graph y equals 25. This puts in a blue horizontal line at the 25 level, and we need to figure out where it's equal to our exponential function. So we're finding where they cross, and that's at this point right here. So the answer for the half-life is 12.25, rounding to 2 decimals.